Welcome to the second class, guys. You can we are going for an example. We analyze this and electric vehicle, how it is controlled is route. Okay, this is a road. You can see this is a road line, middle line. Okay, okay. This is a car. This car want to meet this position. Okay, want to meet this position. So you can see trajectory model. If okay, so it can reach here, it can directly come here. Okay, it can reach in this way, it can reach over there, just okay. In this way, this is one, this is two, this is three. So this car want to meet this road middle line by three way. Actually, I am giving you only the three way. We are considering this, but it may be many way. It may be going in this way also. But as per your requirement, say in front of your this car, there is another car is there. Okay. So as per your choice, you have to select this which path you want to obtain. So first of all, we have to think what are the difficulties, what are the constraint for this each car, each path. So this is called a model, and this model was given automatically given in its memory bank. Say if there is a distance is x, distance is x from this point to this point, and we have to meet this point, then it may take this path. But this position, look, first optimization is there, that the obstacle is in front of this car. If you want to follow this trajectory part, say this is the number 4 lane, but it is not possible because in front of this x distance there is another car is there. So if you go in the same velocity, then it will collide with these vehicles. So this number 4 path is not acceptable. First, this it was cancelled. So only you can see this is 1, 2, 3. These paths are available to you so that you can reach this midpoint within this area. Again, this is also not there. This car may be steady, maybe dynamic. Okay, but what happens? At this position, at this time of t1 second, it is taking only the obstacle. It will never see that it may be dynamic. It may be go away after few seconds. Then it will follow this number of three. It is may be taken or may not be taken as per the program. But first time you can see this four number path is not available. You can't accept this part. So first optimization, this number 4 lane will just delete it. So there is some model is there. So which are the model? First we have to analyze the model first for the first case. Say graph is just like the trajectory path is that in this way. Okay, so if you select x, then if you just break it, you can see that is t1, that is t2, that is t3. Okay, within this car just taking that trajectory. Say this is 45 degree, Then whenever it reach to this position, you can see this portion is not actually 40, this is 45 degree, but this position is not, till now it is not actually 45 degree. Whenever it is come here, that it may be for this t2 second, t2 second, this car, it is coming just like this. So this car is coming over here, this is coming over here, say this is 30 degree, and after this t3 position, t3 position, it is just at the 0 degree, sorry, 0 degree. So this is 40, 45 degree, then 30 degree. From it is starting from the 0 degree, it is going on, not greater than sign. Okay, okay, again it is coming, that is 0 degree. For the second case, say the graphical representation is just like this. This is from this x distance. Okay, so if you slotted it into this t1, t2, and this is t3, so you have to model this. Look, this is also 45, then something it is coming over there. So first time, this is also 45 degree. Then it is coming not 30 degree. Look, this is very less. So this is 15 degree. 15 degree. Okay, just like this. Then again it is going to the 5 degree. Say this is 5 degree, then it will go to the 0 degree. So 0 to 45, then 15, 15, then 5. Okay, then 0. Then the third case, you can see the graphical representation is that say T1, say T2, say T3. You can see this is not 45 degree. Say this is 30 degree. Car is just going in this way. Then again 30 degree. Then again 30 degree. Or sometime less, and after then it will reach to the 0 degree. So this is 0 to 30, sorry, 0 to 30 degree, 30 degree to 30 degree, 30 degree to 30 degree. So you can, whenever you make some model, you can easily find out what are the constant. Look here, 0 to 45 degrees, so deviation is 45. Okay, here 45 to 30, deviation is 15. Here again 30 to 0, so deviation is 30 degree, 30. So this car should jerk enough, means from 0 to suddenly 45 degrees, then gradually 30 degrees, then and it will go into the gradually 30 to 0, so 30 degree you have to deviate it. Here in case you can find out, if you make this graph, look 0 to 45 degree, look in this way, then then this is 15 degree. So whenever it is coming, that is 15 degree, then again it is coming to the 30 degree. Okay, then again it is 0 degree. Okay, in this way But if you make this graph, yes, this is also 45°, then 15, then it is 15 deviation, then again it is going to the 5. Okay, not this is 5, from 15 to this 5, then it is 0. Okay, if you go for this graph, look, here is, that is 30, then 30, then 30, then it is going to the 0. So from this graphical representation, and the controller can find that is so many jerking, so many disturbance are coming over there, but here is very less disturbance is there. And if you go for this disturbance, then very small, one time it is curving, then steady, and then it is going to the 0 position. So in this way, if this model are saying which things you have to apply it. But if there is an obstacle is there at this area, if it is detected that any obstacle is there at this area, though this is very efficient curve, but it is not acceptable, then within this only, look, here jerking is high, but here jerking is very comparatively less, so this model will be acceptable. So this is called model predictive if control system. First, this is from this model, as this model was given to you, I am just giving you only 3 steps only, but there is a lots of steps and bisections is there. Then they select which one is the less jerking, giving yields jerk, which model is giving yields less jerking, um, um, and highest balance. Look, in where is jerk is less, then balance is very high. So in this way, this model will be accepted. So, but if there is a no obstacle is there, then this model 3 will be accepted. Then this model 3 will be accepted. But if there is coming, you can see, if this is going that this card is here, so within this period, this card maybe come here, or if this is dynamic, this card will go on, so then it will be accepted. So in this way, model predictive control system are working. So first the model are given, then it will select which model it need to optimize. So first time I told you the numerical solving on optimization problem at each step. So each step it will check some numerical analysis so that it can optimize which model it has to select. Then it will set the control to follow these two paths. So this path will be selected and it will going on. So for this x distance, this step, then it will be accepted. Again, whenever it will coming here, then again it will analysis for the next step. Then it will going on. So you can write down MPC. This is the features. Simulate the future trajectory. This is called trajectory path. This path is called trajectory path. Okay. The last class we have studied single phase transformer. Trajectory. That class we already discussed about, and that is predicted trajectory. Application of the transformers from the government, and basically here you will find out. So today we are going to discuss then some other component of the transformer. Then like it go for condition. Today we are going to write the applied and optimized. Optimization. So this is the MPC. And what is the working? What is the applicable? Look, It can handle.
Sir,
Yes, tell me.
sir, so, sir, sir, please show the previous slide.
Here,
No, sir, what you are writing, this slide.
which slide? Here.
Go to for the sir.
Okay.
Right and scroll, scroll down, sir. Thank you.
Okay.
It's okay, sir. Thank you.
Okay. Okay. It can handle multi-input, multi-input and multi-output system. Okay. And input of a particular system can change other output. Okay. So it can handle multi-input, multi-output system, and any one input can change other output. So just draw the controller. First one is that is reference. Means this is reference input one. Okay, that is reference one. That is reference two. Reference two, and that is going to the nth order. Reference n. Okay, this is input. So each one has some control strategy, and it is going on some PID controller. This is process. Output. It has some feedback also. Okay. In this way, there is something is there. Here also, this is nth reference, means n output. That is PID controller in. Feedback in. Look, this is process. Okay. So this is the array of this process. Operating principle of the transformer is clear to all of you, or has any doubt asking? Operating principle of transformer. So they are told that an input of particular system can change the other output. It can handle multi-input, multi-output. It can handle multi-input and multi-output. Okay, But these things, you can see these things, one things change to the output. Here is the difference with the other. That is, one input change the other, and it can change also the output. Okay, because if speed is required but obstacle is there, so obstacle and speed is controlled by each other. Okay, trajectory model, say this is a trajectory model and this is a speed. So trajectory model can operate the control the speed. Otherwise, say it is going here but you are taking only 10 kilometer per hour, it will not reach at this time. But if you go for the 100 kilometer, but you want to reach in this way, but so what happens if you go for the 100 kilometer per hour and you want to reach up to this within this time too, it may be going to the out. Okay, it may be going to the out of this track because speed is high. So speed should be controlled as per the trajectory model. Speed should be controlled as per the obstacle, or the trajectory model can be selected as per your obstacle, as per your time. So this is a multi-input, multi-output control system, and each this is a multi-input, multi-output system. Look, this is, if this is a x1, this is a xn, this is the output y1 and yn, and the features is that each input of the other reference can be control the other output. So in this way it is controlled. Okay, so another features is coming, that is it can control all the output simultaneously. Okay, as it is multivariable, multivariable controller taking all variable interaction. Okay, so you have chosen first time, that is the second trajectory. Within this, only this second path was chosen. So you have to select the speed. Say this is your car. It is sinusoidal. So current is also sinusoidal. Okay. So due to this current flowing in this coil, flux produced. So this flux is also. If this is your car, I am just. This is supply voltage is sinusoidal. So exciting current comes from the supply to this. This is your car. This trajectory is chosen. That is similarly small value of phi equal to phi maximum sin omega t. But here another car is there. Phi maximum. That is another car is there. Case of electromagnetic induction and then tell me the everything is value of RMS value. That is E1. Anyone. Another car is there. Though this is, you have seen in this position x distance is required, but that is T1, that is T2, T3. So this car is coming. This is constraint. Another car is coming. So you have first speed was select for this 60 kilometer per hour. But if it is selected that 60 kilometer per hour, so there is a collision. So it will just change its things, so that this is 60, then it is 45 kilometer, it is coming here. Look, this is also passing, this is also passing. So after then it is going to the 35 kilometer per hour. So in this way it is the speed control. If it is going in this way, then no collision is occurred. But if it only 60 kilometer was selected, then it will be the collision. So this speed also control the trajectory. Okay, this speed also controlled. So this speed will be controlled as per the trajectory. So this is the fundamental things of the MPC. So I'm going to the next slide.
Excuse
Yes,
me.
yes, yes, tell me.
Hello.
Yes, yes, tell me.
Sir, can you kindly explain this
Okay,
control?
for this control, now in previous slide you have
Yes,
seen,
sir. Yes, sir.
previously a slide is here. In this slide, hello guys, hello,
So last one.
last one. Okay, so from this MPC you can find this two trajectory model was selected. Two trajectory model was selected. But now what happens whenever it is two trajectory model was selected, then it was given that within this time, say for this is 30 second, it will reach this x distance if we go for 60 kilometer per hour. Okay, this is the condition. It was selected, it will follow this thing. First time after the t1 second it will follow, but whenever it will reach to this t1 second, it has seen that another car is coming. This is our main car. Okay, but another this red car is coming at this position. So what happens? Is it okay to follow the 60 kilometer per hour? If it is following the 60 kilometer per hour here, then it will be a collision. Then it will be an accident. Then what happens? Because another input which is controlling the speed and obstacles, one controller is controlling the trajectory path, another controller is controlling the speed and trajectory, speed and obstacle. It will always watching this. Here is some obstacle is there at this moment. So what happened? It will control the speed, but it will control the speed. Then what happens? If this is a 60 kilometer per hour, then it will measure that this trajectory part, if we go for this trajectory part, then it will be accident. So then automatically it will reduce this part. Either it will change its trajectory, then again it will consider for the another trajectory part, so that it will cross over this car, or it will change the speed also. So first time they are changing the speed also, so it will change its speed as per. Here is also a model is there. If within this x, say this is a y distance is there, if there is an obstacle, then it will, if it is going to the reach to the obstacle, then it will reduce the 50% or say 80% reduce. So this is it will t1, this is t2, this is t3. So it will reduce the 30% speed. So 60 of 30 and make abruptly 45. Again it will measure whether the distance, then again it will reduce to the 30% distance. Yes, this is now it is 15 kilometer per hour, or it may be 25 kilometer hour. Again it is watching this. Yes, no collision is there, it will go on. Within doing this, it will reach to this midpoint. Okay, in this way, because this car was going away, this car was passing away, because this car also dynamic. So if this car is coming, it is going to in position, and this car is coming here. This green car is reached, this car is reached here, but here the red car was here, red car was here. So red car is going in this way, and this car is also our objective car is reached in this way. So you can see multi-input and multi-output control. You need here multi-input and multi-output, as well as each input can control to the other output. So if this trajectory is required, then we have to control the speed. Speed also a model. Here speed also a model you have given, because lots of things are there. And whenever speed is controlled, then we'll easily reach it. But if you select no, I need speed should be 60 kilometer, then this trajectory, because this car was this red car was at this position, red car was at this position. It is seen that red car is as position, but if you select this 60 kilometer per hour and trajectory 2, then it will be collision. So either you have to change your speed, either have to change your trajectory. Okay, so one input can change other. If trajectory is selected, then speed should be controlled. If speed is selected, then trajectory should be controlled. So these things is happened here. These things is happened here. One input can change other output. Speed is sorry, trajectory is changing the speed. Or if you select speed is fixed, then speed will change the trajectory path. So in this way, this MPC is working. So guys, is that clear to you? Now speed is changing. Sorry,
Yes, sir.
trajectory is changing the speed. So in this way, MPC is working. Okay. So another thing is just remember, only few minutes is left. Just like when jerking is there, when banking is there, say this is a car. Here it is 60 kilometer. Here this is 20 kilometer, and again this position 20 kilometer. Okay, so 60 to 20, you can see the whenever banking is required, you know the human should be tilt just like this. Human should be tilt just like this. Okay, this 45-degree. But if the MPC is there, what happens? MPC can, this is your car, this is your car, this is your car, it is coming in this banking. But if there is a MPC is there, this is your red color, this car is there, it watch that is here is some banking is there, so it will just reduce its, this is MPC, this is manual. Okay, manual is coming whenever this coming 60 to 20, it is coming 50, it is coming 40, it is coming 30, here it is coming 20, and again it is going 20, and again it is going 30, 40 and 60. In this way, if you watch this position, then this car became very less. Human can tilt very less. Say this is. So you can see this human can, you have to jerk whenever jerking is there, banking is there, you have to tilt so 45-degree, but here only 10-degree tilting is required for the MPC control. Because if you go for this graphical representation, then one, and this is going on, then again 60 to 20, again it is going on. But in this case, you can see gradual decrease and increase. This is kilometer, this is kilometer, 6, and this is time. So MPC we can model just like this. Reference, Okay, this is reference and this is optimizer and this is trajectory model.
Okay, so we are going to find out the level reduced in the
Optimizer
we are going to 4.44
and this is trajectory.
number of cars. Okay, one here represent for the transit file or supply side file. Okay.
Trajectory model.
We will find out
Okay.
on the secondary side. That means you write down suffix
Trajectory model.
2 RL.
So these are the internally connected. They are internally controlled. Then it is going to the process.
That is micro plus density into area. Okay.
That is output.
N1, that is number of turns to be satisfied. Here, write down N in the form of any file. Okay. So, if you write for primary side file or secondary side file, you represent 1
Okay.
and 2.
This is the MPC model. This is MPC model. Okay, guys. This is your MPC model. Look, optimizer can control the trajectory. Trajectory model can trajectory is optimized. Okay, in this way it is going on. This is a one loop. There is a lots of loops are there. Okay, for each control system there is a one loop. Okay, guys, up to this I think you are getting this MPC concept. If you have any question, you may ask me. Otherwise, I am going to stop here. Hello, guys. Have you any question? Then I am going
No,
to.
sir, it's okay.
Okay, thank you. Thank you. Have a nice day.
Thank you, sir.
Four type of transformer. So 4 type of transformer.